and it bridges between cerebellum and brainstem and between medulla and higher levels of the brain. The pons produces what we call norepinephrine. Locus coeruleus is a structure within the pons that produces norepinephrine, important for a state of arousal. Raphe nuclei are structures that are very important when it comes to the production of serotonin. So please make note that when you take a look at the brainstem area is where a lot of these neurotransmitters are produced, and then the production of these neurotransmitters at the brainstem area gets projected to the rest of the brain towards function. So locus coeruleus or coeruleus, depending whether you're Greek or Latin, produces norepinephrine. Norepinephrine is a very important chemical. It tends to heighten in its production when it comes to arousal, when you're in a situation of a fear response, you're in a situation of a novel information, like, for example, meeting someone for the first time or attracted to someone, you get to heighten that level of norepinephrine. Your sensory systems are very much acute. They can tune in. You can listen to specifics. Your auditory system gets heightened in its ability to listen to information. Your visual system gets heightened to see the world around you. So norepinephrine has an effect on those ability to process information around you. Raphe nuclei produces serotonin, and you get to learn in the next chapter that serotonin is very important when it comes to mood and thinking. One of the things I would like to include the pons here, folks, is the pons is very important when it comes to REM sleep. The onset of REM sleep is very much relating to the pons. So please make note of that. So when it's ready to go to REM sleep, the pons gets activated, and then it talks to the thalamus. The thalamus then talks to the occipital lobe. Occipital lobe then engages an association cortices that would result to experience such as dreaming. So when it comes to dreaming, the pathway really is originating from the pons to the thalamus to the occipital lobe and to the association cortex of the brain. Reality, on the other hand, the input of information comes from your sensory organs, from your eyes, your nose, your ears. Those information will travel to the thalamus. Thalamus then will communicate to particularly the occipital lobe and other areas of the brain so that you can process what you just saw, what you just heard, what you just tasted, and then you have what we call perception. So there are different types of perception. You have distortion of perception, which is seen in hallucination. And hallucination is basically activation of the cortex, whereas when it comes to dreaming, it activates the pons, the thalamus, the occipital lobe. When it comes to reality, it originates from your sensory organs. It goes to the thalamus and to the rest of the brain for processing. So when it comes to perception of information, it can be due to reality, it can be due to dreaming, or it can be due to hallucination. So it's a very interesting dynamic and very interesting pathways. If you want to expand on this with me, I welcome you to my community forum next week on Tuesday. We'll be having a community forum on Tuesday next week. So look for the announcement. The hindbrain comprised, in addition to the pons, we have the cerebellum. Remember, please make note that the pons and the cerebellum